Okay, well, I just thought I'd put a little update video on the channel, kind of show where I'm at with the truck. So you can see I cleaned the deck off there. I just used a little piece of brown 3M scouring pad and put some rags down to protect the journals of the crankshaft. It cleaned up pretty nice. Just want to have a good surface for the new Permatech Felpro Permatech head gasket. And then you can see I'm over here working away. Let's see, what is the latest here? I guess I might have mentioned in the other video, I pulled the cylinder head apart. I have all the valves in plastic bags in the back of the pickup truck, and just going through cleaning the surfaces. You can kind of see here along this area here, clean that all up. As I might have shown in my previous video, I opened up that oil return hole here. It's about double the passageway now. So I'm interested to see if that makes any difference on the whole oil baffle situation. Maybe I'll be able to run a little bit more vacuum in the crankcase. Hard to say. I still need to clean the head. I'm working on it. I'm gonna lap the valves in. I saw a neat little trick where a guy put valves in, and you can see over here my valve compressor came with these little guys. I was going to give these a shot. When I was younger, I've done valve jobs this way. It's kind of tedious, but and then you can kind of see these are the stock pistons and everything that I showed in some of the other videos. The trick I saw was pretty cool though on YouTube there somewhere. You just put the valve in with the grinding compound, put it up against the seat, and the part that sticks out, you just put a little rubber hose on it and then clamp a drill chuck down and spin it as you pull back. So I thought I might give that a try. You can see in the LC Engineering head they use I believe these are Viton rubber seals. Somewhere floating around here, maybe back here somewhere, and you can kind of see this is the state of the motor here. Somewhere floating around here I got a set of new seals, which I was going to put them in, but I kind of also just bought them for, in case I accidentally mess one of the seals up. I'm not entirely sure. I think they're in a box over there. I'm not entirely sure how they come on and off. I was going to give the guys over at LC Engineering a call and ask them about that. Let's see, in other news, I pressed in the ARP rod bolts there. They come with their own little kind of hex nuts. Now these are, you got to be careful because these are actually 7/16. I had to buy a special impact socket that would be extra strong in a tight space here. I don't have a lot of standard sockets, and I didn't have anything kind of specialized for that 12-point affair that ARP uses. I don't know if I mentioned in the previous video, I ended up getting some Federal Mogul bearings, tri-metal, 20 thousandths over. So I slapped those in. Most of my precision measuring stuff is packed up at my new location where I'm moving to. So I had to bite the bullet and order duplicate tools, which I really hate doing. But I found a cool 3 to 4 inch micrometer used, coming from the East Coast. And also I picked up a nice vintage Japanese bore gauge from 2 to 6 inches. Maybe I'll show that in another video. I'll tell you what, our power was out for 3 or 4 days. It just came back on, so I'm getting back to work on the truck here. You can see also, I'm in the process, I was cleaning up this the intake runners here, and I'm gonna. You can see I've laid it up with Dicom blue, or the machinist blue. I'm gonna get the. I've already matched the intake gasket to the porting on the LC cylinder head, and then I'm going to transfer that over and scribe a line here, and then I've got some carbide bits and some of these little, pick these up off Amazon. Normally I grab these at the welding supply store, and I have a whole bunch, but again they're packed up and ready to move to the new location. So I ended up ordering these off of Amazon. We'll see how they do. I forget the exact brand name that I use from the welding supply store, but these were rated for, 35,000 RPMs or something like that. So I suspect they're a little bit higher quality. So I'll use a combination of these and my carbide cutting bits, which I have a growing collection of now from Timo. If you're looking for carbide cutting stuff, Timo on Amazon makes fantastic double cut and single cut for aluminum carbide bits. If anyone's curious, I'm happy to put the links to the ones I buy in the description. Also, picked up a set of Keith Black Pistons, and I've been going over the installation instructions and getting back up to speed on ring gaps. I might have mentioned in a previous video that I was going to set the gaps to 4 thousandths per inch of bore. Now, based on what I've read here on the actual Keith Black Pistons, as well as the information I found online and for the total seal rings, I've come to the conclusion that I'm probably going to go somewhere around 7 thousandths and perhaps as high as 8.5 thousandths on my ring gaps, top and bottom, when I put these pistons in. Excuse me. There's a couple of reasons for that. In my research, and these are the Keith Black Pistons. I bought these from Summit Racing. These are the ones for the 22RE. Overall, they look all right. There was one. Let me see if I can find it here. There was one. Oh yeah, here. There was one that had a nasty ding in it. There was actually two that had little dings in them, and this one had raised a burr to the point where I had to hit it with a jeweler's file, and it knocked off a little bit of this, whatever this coating, anti-scuff coating they put on their pistons. I wasn't super thrilled about that, but given the damage in cylinder number 2, that is the least of my concerns on the motor. As I might have mentioned, I don't know where the other piston that was damaged is, or I shouldn't say damaged, just dinged up a little bit. If the guys at Keith Black are watching my video, maybe step up the old quality control over there a touch. By and large, oh here, I think it was this one here that had little well, anyway, one of them had another ding, I can't remember, but it didn't really need much attention as I remember. Pistons are good. These are the Hyper Eutectic pistons. For the money, pretty happy with these. I'll say one thing: they have a expansion area here for bypass pressure that gets past the top ring, so it has somewhere to go. I was pleased to see that. You can look at the stock piston, and it does not have that, so that's a step in the right direction. The other thing I was very happy to discover was that the second compression ring on the Keith Black Pistons is a full 1.5 millimeters lower. And if you saw my previous video, I've got a little damage here on the top of cylinder number 2, right near the top. So anything to move the second compression ring down is good news for me. Why they do that on the pistons with the Keith Black Pistons versus the stock, I don't know. I suspect it has to do with this pressure kind of relief area. And like I said, that just gives a little more volume for any gases that get past the first ring to have somewhere to kind of go. And so that's nice. These are higher compression. Stock 22RE, as you probably already know, is 9:1 compression. These bump it up to 9.7, and given that these are 20 thousandths or half a millimeter over, is probably even just a hair above that. They use spiral locking rings, which will be fun, and they have a slightly smaller rod for the small end of the connecting rods, piston pin, I should say. I haven't weighed them yet. I'm gonna weight match all the pistons later today or tomorrow probably. Also balance out the big end and the little end of the rods, mostly the big end. Make sure all the reciprocating mass is kind of in the same ballpark. You know, down to maybe a tenth of a gram if I can get it. Let's see, what else was I going to point out? I guess that's a bit. Oh, I know it. In my research with these hyper-eutectic pistons, which basically they just have a higher silicon content in the aluminum, there was mention of the fact that these reflect more heat. In reading some of the literature on these pistons in general, there was a mention that they reflect more heat up into the combustion chamber from the piston, and as such you may need to run a little bit higher gap. So that's kind of why I'll be running probably 8.5 thousandths or 7.5 thousandths on my rings per inch of bore, not total, of course. The other reason I was going to do that was just as a safety margin. We're not, on a good day, the 22R in this trim here, port matched, cam, cylinder head, big valves. On a good day, you might be getting 135 or 40 horsepower at the crank. So we're not exactly talking about a TJZ here. So I'm being a little bit lax with some of my approach, a little different than I would on a full-blown race motor. So I'm erring on the side of having my piston ring gap larger than smaller, and also given that every single upper compression ring snapped on the stock pistons, I have a suspicion that that's a byproduct of the engine overheating once. It's a long story. I won't go into it right now. It was when I was first starting to learn about the 22RE and I had the timing out of whack. It's either that, or when I'm towing stuff in the truck, or I have the truck fully loaded and I'm going up and over some very large hills at very high speeds, I have noticed that the oil temperature climbs up into the 220, 225 range. It's not for an extended period of time, but I'm wondering now if the person who built the lower end might have been running overly tight ring gaps. And, when I was running the truck, or the time it overheated, or maybe because I'm running slightly hotter plugs, perhaps the ends buckled up and fractured the rings, and then from there it was kind of downhill. So to make sure that doesn't happen while I'm running the 22RE, I'm going to run, kind of what most people would consider kind of large gaps on my rings. So not worried too much about a little extra blow-by. And then we'll just kind of see how that goes. So that's kind of where things stand. Start slowly knocking down kind of what's needed to be done here to get the motor back together, and then we'll see how everything shakes out. Let me think if there's anything else I wanted to mention. I guess that's about it. Oh, I did have to, you may have noticed that my beloved Braille G30 battery is out of the truck. That's because while our power was out for 3 days, I ended up having to use that Braille battery as a power bank to charge up my iPhone and my iPad and all that. It did a terrific job, so I took it up to the kitchen with its little charger and charged it back up. Had it not been for the Braille battery, I would have been completely in the dark for the last few days. So luckily that thing really saved the day. Let's see. I guess that's about it. So that's the latest. Getting the valves done here soon enough, and get the cylinder head back together. Port matching on the intake runners. I got a couple of different intake gaskets coming. I'm going to size up. Not super thrilled with the Felpro one, which is lurking around here somewhere. It's got these jobbies here. And you can see in the areas where I brought the gasket out to meet the porting work on the LC Engineering head, in a couple areas it got awfully close. Might not be a big deal, but for $10 off Amazon, I thought I'd get the other gasket and see how it goes. Let me walk around here real quick and show you the Permatech head gasket I like. Any of you guys out there building 22REs rather. This is the head gasket to use, in my opinion. And I mentioned it in a previous video. It's the Felpro 26185 PT, which stands for Permatorque. Now, I called the companies who manufacture these and asked to speak with the engineers anyone who would know a thing or two about how their head gaskets are made. I was able to get a hold of a gentleman at Felpro who really knew his business, and I asked him about this specific and what makes it so good. And he told me that it has Kevlar in it as well as Teflon, which I was really happy to hear everything he had to say. And I decided to use this gasket because as you may or may not know, the expansion coefficient of aluminum is slightly different than that of cast iron. And so having that Teflon in the mix allows the head to slip and slide on the block. And having Kevlar also in the gasket, assuming everything you told me is accurate and I'm relaying it correctly, should make this a really great gasket. The one that I took off, which is sitting over there on the bench, the one that I took off came off the motor. Granted, it was only about 6,000 or 7,000 miles, but it came off the motor looking as good as when I put it on. So if you're pulling the head off your 22RE, that's a head gasket to really strongly consider, I think. Might have shown these in the previous video. Total seal, these are the rings. And as soon as I have a chance, I'm gonna get to work gapping those guys and getting all the intake ports matched. Something else I wanted to comment on was, if you watched my previous rebuild video on this particular motor, you might have seen me mention that I pre-oiled the valve train stuff here before I put the cylinder head on. And I had a thought the other night, when it came to torquing down the head bolts, I noticed on this one here, this particular head bolt, I torqued it down to 60 3 foot-pounds. Then I came back later, torqued it down to 66. And two separate times, when I checked the head bolts, they were all fine at 66 foot-pounds, except this little guy. And twice in a row it moved, and I was trying to figure out why that would be. And the only thing I can think is that with this little hole here, when I put oil into the valve train assembly, I think some of that oil might have gotten down into the head bolt holes before I got the head bolts in. And that, excuse me, that might have put back pressure up on that head bolt. More importantly, that can be a very, very serious situation that you created, or I've created. If you have too much oil in there and you're torquing down the head bolts, you can create a hydraulic situation which the head bolt pushes down on that oil, which will not compress, and it can actually crack the block. I know of cases, I don't know if it was related specifically to Toyotas, but I do know of cases where engine builders or people working on their cars have inadvertently fractured the block by having oil or coolant in those holes. So when I do it, I clean them out and I chase them. And this time around, I'm not going to pre-oil that assembly because I don't want to get any oil down into the head bolt holes. What I will do is I'll use some ultra slick assembly lube, but I'll put that on everything after I assemble, after I torque the head bolts. And then what I'm going to do is I'm going to pull the fuse for the EFI on the ECU, the fuel injection fuse. I'm going to pull that out, and then I'm just going to crank the engine over with the starter only without it firing up in order to build up the oil pressure for when I first fire it. The other interesting thing I wanted to mention was I was talking to this guy on the Ferrari forum, and he was having a problem with one of his with his BMW engine, and we got to talking, and the problem related to BMW's Vanos system, which is like a variable cam timing sort of thing. But in talking with this gentleman, he mentioned that the 2 times they had rebuilt his BMW motor, they had fired it up on mineral oil, which as many engines as I built, I never heard of that. I looked it up. Sure enough, apparently it's a thing that people do, especially in the aviation industry with airplane motors. Did some further research as to why people do that, and came to the conclusion that I want to do that too, because it aids in seating the piston rings, which is something I want to have my piston rings seat as much as possible and cut down this crazy oil consumption. So I did a little search around. I'm not running, I'm not going to fill the motor up with just a can of mineral oil, but what I did find was Lucas makes break-in oil, which is probably the same thing. And so what I'm going to do is when I fire this motor back up, and I'll try to get it on video for everyone who's subscribed. I'm going to break it in, and I've already got the oil sitting over there in the cabinet. I'm going to break it in with Lucas 30 weight engine break-in oil, and maybe run the motor for 500 or 1,000 miles on that before I switch to the new oil, which I'm going to try, which is the liquid moly. I forget which one it is, but I think it was a 10W40 weight oil. Also, if you guys have been watching the channel for a long time, you know that I've tried a lot of different oils in my motor. Everything from 0W20 clear up to 15W60, I think, Rotella. And after reading and researching about the connecting rod bearings, as well as examining the ones over here that came out of the motor and seeing some of the condition of them, well, you can see right there it's down to the copper, or the bronze rather. After doing that research on and really studying up on these connecting rod bearings and so forth, I decided I'm not going to do that anymore. And the other thing I'm not going to do is run Motor Medic engine flush through the engine at all, ever. So I think I'm going to stick to 10W40 oil to have a little extra thickness in the bearing department, and maybe if it gets really cold I'll drop it down to 10W30. So okay, that video went a little long, but there's kind of a lot of stuff I wanted to just mention, primarily because if somebody comes along watching the videos and they're working on their 22RE or building a motor or whatever, some of these little tips that I've run across with having to rebuild this motor a few times. Maybe little things will jump out and say, oh yeah, that's a good idea, or oh hey, look how this guy does that thing over there. And that's really how I've learned when it comes to working on the motors and stuff over the years, is just watching lots and lots of YouTube videos and reading lots and lots of articles and forums. So try to pass that along. Okay, that's the latest for now. We're getting things back together. Hopefully have the truck back on the road sometime later January, so maybe another 15 or 20 days if all goes well. I'll once I get a little more work done, I'll update things a little further. All right, as always, any questions on anything, feel free to use that comment section below, and thanks very much for watching.